We're back with another episode of How Many Candy Corns Are in This Jar? Except in this episode, we're going to reveal the real number. So, it's so exciting. All right. In our data set so far, we collected data from our class, from some of my family and friends. So we had 44 data values for how many candy corns we thought were in this jar. So far in our class, we've analyzed this data set. We've found the mean, the standard deviation. We've made histograms, things like this to kind of look at the distribution of the data set and how it looked and everything. So I actually want to pull up our class data set from that here and just kind of remind ourselves of what was going on. So here's our data set. These are all of our guesses. And I want to really recall the measures of central tendency for this data set. So we had the mean was about 428.73. So I'm just going to round up to about 429 was the average guess. The median, meaning the very middle of our data set, if we were to look at put them in order, the very middle is 344, and then the mode was 340, but I mentioned in a previous video, every number here in this data set was guessed only once, except for 340, which was guessed twice. So I put that like an asterisk next to mode. It wasn't like this mode was guessed, significantly more times than other numbers. But again, I highlighted the mean and median here because this is a very important comparison as we've seen in our course. So when we look at the mean and median, what's going on is the median is the very middle of the data set. And for the mean to be greater than the median, what's happening is we have some higher guesses that are pulling the average, that are kind of pulling or weighing the average larger than the very middle of the data set. So this data set is skewed right, if we recall. So I'm going to go back into our candy corn reveal now. All right, so back over here, reminding ourselves of kind of how we guessed before I reveal this answer. I want to highlight some of what you all were guessing in our group discussion. And a lot of you tried and went through various reasonings, and I want to highlight a lot of them. Not all of you did calculations, which is amazing, and a lot of you used either different logical reasoning or literally just took a wild guess, which I appreciate. And I still think there's logic behind your wild guess. So it's not really just a random number. There's reasoning why you chose that. So kind of here, this person I want to point out kind of broke down in steps how they thought about this. So they thought about the volume. So volume is not necessarily something we associate too much with statistics, but it is in this case because this is an experiment where we have filled a jar. And so a lot of you use the idea of volume. You went and either found formulas for volume or you remember formulas for volume of either a cylinder or this person, for example, a truncated cone to talk about the actual candy corns. Just really creative stuff here. So this person ended up coming up with a guess of 346 about. This person did something similar in terms of looking at volume, kind of comparing the idea of how much a size of a candy corn would be, and then taking the volume of the jar and dividing it by the volume of a candy corn to see how many. You're essentially doing conversions, like unit conversions here. And two, something I want to emphasize is that a lot of you did these calculations and came up with very different guesses, which is very interesting, and there's nothing wrong with this. My point is math is all personal. Math is all individual. And I think it's amazing the way each of you thought through this problem. So I'm just highlighting a lot of them. And please know I just didn't have time to talk through all of your guesses. So I just kind of took like a representative sample, but a lot of you did really, really cool things. So this is another person that kind of talked about the jar, and what they did is they actually kind of looked at it more of like a layer. So they looked at like one layer might be 8 by 8, and then they multiplied it by the number of layers in the jar, which is volume as a concept. They also added 25% more in case it was packed very tightly. And I will go back to this other one here. This person highlighted that they thought maybe there was empty space. So instead of adding, thinking that there's packed in there, this person kind of removed some of their guess because of, there's kind of, the candy corns might have some empty space in between them. And again, just really, really cool reasoning here. Okay. All right. This person, initially they just wanted to guess 700. I'm going to move myself because I'm in the way. Initially they wanted to guess 700 candy corns in the jar. They did a lot of calculations and then they ended up coming up with 926. And they said, well, that's more than I expected. So I also want to really, I'll say, I acknowledge a lot of you used logic even after your guesses, after your calculations. And so you came up with a number and then a lot of you reflected on that number, which is very important in mathematics and statistics, is to make sense of what you're guessing, right? So don't just, substitute in numbers and go with it, but make sure that it makes sense to you, because that's what's really the most important here. All right, let's look at some others. Okay, so now we're going to get into some examples of maybe not so much calculation. There's other logical reasoning here. So this person decided 200 feels like pretty good. They tried some calculations and they feel like whatever number they had was too high, so they decided to go with 200. Okay, this person just wanted to have fun with it. They didn't want to take it too seriously, which I love. So they didn't want to get too technical. They said it ruins the game, so they guessed 135. This person decided to think about, okay, instead of the whole jar or calculating a layer, if I just think about a cup, how many candy corns do I think would fit in a cup? And then how many cups would fit in the jar would help that person make their guess. Here, this person, they actually looked at like the width of my hand. So they assumed or calculated or Googled the average width of adult hands and used that as kind of like a scale. So someone else also used your phone. Like you said, you put your phone next to, think about how many candy corns would line up next to your phone. It's amazing how resourceful y'all were. This person Googled and said, they literally Googled how many candy corns would fit in, the dimension of a candy corn is 1.4 milliliters. And they Googled how many milliliters are in a 16-ounce jar and then did their calculations that way. I will point out too, some of you used artificial intelligence, AI. My brother used AI. He actually uploaded a picture of me from my video to get a guess for this, which was fair game. Y'all were allowed to do whatever you wanted to. Okay, this person came up with 547. They also did some of this calculation. And a lot of the volume calculations that y'all were doing, you were doing with different units. So I want to point out again, you can do calculations in a lot of different ways and come up with different guesses. It's really creative. Okay, this person went out and bought a jar that they thought was similar to this one and then bought candy corn. I'm sorry, they had a jar at home. Someone else though, someone else in the chat bought a candy corn, bought a jar and filled it with candy corns. This person had a similar jar at home, so they went and bought candy corns, filled it up, and they ended up coming up with a guess after kind of estimating a few more handfuls of 350. What's really cool about that, those of you, because a couple of you did something similar like this, is that you are literally reproducing a statistical experiment. So in our course, if you recall, we've been learning about experiments and probabilities of success. That's kind of where we're going in this further analysis in our next video here. But y'all are reproducing this experiment. Y'all are looking at different sample sizes. You are using an example and reproducing statistical ideas, which is really, really cool. All right. This person, it was the first number that came to mind, 237. Love it. And again, I really want to emphasize, those of you who did just take a random guess, it wasn't really completely random. There was some level of logic as to how many reasonable candy corns were in that jar. So I just want to mention that. Okay, and the true number is 343. That's how many candy corns were in here. And I'm going to highlight the person who guessed the closest was one away. So they guessed 342. And by the way, I didn't put any of your names on these because it's going on YouTube and I would like to ask your permission before I did that. So there are 342 candy corns was what this person guessed. And they said, basically, I didn't think it could be over 400. So I'm going to take a guess at 342. And this is a good point as well, that no matter how much we use math and statistics to model and make predictions, because that really is what statistics is about, we can use a lot of data, a lot of educated guesses to predict things. But in real life, anything can happen. And so sometimes there's randomness involved, which I'm highlighting with this guess. So, and then really quick, I just want to bring back up data from our guesses. So the real number was 343. And I want to point out the mean was 344. So if you ever need evidence of the measures of central tendency, so we've learned sometimes that the mean, the average, is not the best guess for a data set because we have skewness. And again, if the data set is skewed, that means the mean is being pulled in some direction. You have some guesses that are either higher or lower in such a way that's pulling the mean away from the middle, the median. And so in this case, the median was 344, which was one away from the true value. And that's what's really cool about this. If y'all ever have to guess anymore for things like this, if you wait until the end of everyone's guesses and either look at the mean or the median, you have a pretty good guess as to how many things are in that jar. So that's just a little hint for future reference. You might win a little competition or something in the future. But all right, well, that's going to be it for us in this video. And in the next video, we're going to jump into analyzing kind of y'all's guesses in different ways. So for example, what proportion of you guessed less than the actual number? What proportion of you guessed greater than the actual number? Maybe even looking at what proportion of you guessed within a standard deviation of the real number, kind of comparing that to the empirical rule or Chebyshev's rule that we have studied. So that'll be it for this video. In our next video, we'll analyze some of our data.